Good morning, students. In this section we will discuss about low loss transmission lines. Simply, in our previous sections we have discussed lossless transmission line and distortionless transmission line. Now we are going to discuss about low loss transmission line. Here, in case of low loss transmission line, we have a small condition to satisfy a transmission line is a low loss, that is at very high frequencies. At very high frequency, the values of R is far less than omega L and G is far less than omega C. These are the two conditions in case of lossless transmission line. That means at very high frequency values, R and G can be neglected. R and G values can be neglected in this case of low loss transmission line. Now, by considering these values, just simply we have to calculate the rest of the parameters, propagation constant, characteristic impedance, all those. Next, for that we have propagation constant gamma equal to square root of R plus j omega L into G plus j omega C. It is the expression for propagation constant. Now I am taking j omega L as a common term from this. J omega L as a common term. Then it will become 1 plus 1 means from this j omega L is common, plus 1 by R by j omega L. There is no component of j omega L at this. So within the denominator we are getting j omega L. And here we are taking j omega C as a common. So 1 plus G by j omega C. Now with this I am writing here j omega whole square LC into 1 plus R by j omega L into 1 plus G by j omega C square root of. Now I am taking this j omega whole square LC out from the root. Then j omega and root LC. Here it is j omega whole square and this one root cancel. Then we are getting j omega root LC into 1 plus R by j omega L whole power 1 by 2. This root here I am writing as power 1 by 2. And similarly 1 plus G by j omega C whole power 1 by 2. Now I am using one formula to expand this. That is simply 1 plus x whole power n equal to 1 plus x by 2 factorial plus up to so on. It is a general formula we have. Similarly, we have 1 minus x whole power n equal to 1 minus x by 2 factorial plus up to so on. That is the small formula. Now I am using this formula to expand this. Here the value of 1 is 1, x is here R by j omega L, here G by j omega C, and n value is 1 by 2. So now I am expanding here. By expanding j omega root LC into this one, 1 plus x by 2 factorial plus up to so on. So 1 plus x value means this entire term R by j omega L into 2 factorial means 2. 2 factorial means 2 into 1 plus G by j omega C into 2 factorial means 2. Now it is expanded by using this formula. Now I am multiplying internally. So j omega root LC into 1 into 1 1 plus 1 into g by 2 j omega c g by 2 j omega c plus this term is over. Now r by 2 j omega l into 1 r by 2 j omega l plus this one into this one, that is r into g rg by 2 into 2 4 j into j j square omega into omega omega square l into c lc. Now here j omega root lc into 1 plus, now I am eliminating higher order terms. This is the higher order term. That means at high frequency those higher order terms can be neglected. So I am eliminating this higher order term. So just eliminate that term. So 1 plus g by 2j omega c plus r by 2j omega l. Now I am multiplying here internally. This term is multiplied internally. J omega root LC into 1 j omega root LC plus j omega root LC into this one j omega root LC into this one g by 2j omega c plus j omega root LC into this one j omega root LC into r by 2j omega l. These are the terms. Now I am cancelling some terms here. That is, simply I can write here j omega root LC plus here j omega, here is root c in the denominator c, here it is root c in the denominator c, then root c get cancelled, and rest here we are having root l by c into simply this 2j omega cancel. So just eliminate it. Here j omega will cancel into g by 2, and similarly plus here root l here root l will be cancelled. Square root of c is present here in the denominator, root l into r by 2. It is gamma. Now gamma can be written as alpha plus j beta is equal to j omega root LC plus this one root L by C into G by 2 plus this one square root of C by L into R by 2. Now I am comparing the real and imaginary parts. Now compare real parts. Yes, now comparing real parts here, alpha here at this side, alpha equal to, here the real parts are those parts which are not having imaginary term, that means j term. So here it is alpha at this side, this is the real part. So square root of L by C into G by 2 plus square root of C by L into R by 2. It is alpha. And now compare imaginary parts. Imaginary parts means here it is j beta equal to at this side j omega root LC. Now j will get cancelled. Beta equal to omega root LC. Omega root LC. Now the propagation phase velocity v suffix p, phase velocity equal to omega by beta. That is omega by beta is nothing but omega root LC. Omega will get cancelled, that means 1 by root LC. These are the points. And now final point, characteristic impedance Z0. Characteristic impedance Z0. For Z0 we have square root of r plus j omega L by g plus j omega C. Now here also I am taking r as a common term and g as a common term. By taking here, similarly here also I am taking from the numerator j omega L as a common term, then it will become 1 plus r by j omega L. From the denominator j omega C as a common term, it will become 1 plus g by j omega C. Here j omega will get cancelled, that equal to square root of L by C into, for this one, 1 plus r by j omega L whole power 1 by 2. This root can be written as 1 by 2 by 1 plus g by j omega C whole power 1 by 2. That root is written. Now I am taking this term into the numerator. Then it will become, here it is plus 1 by 2. When it will becomes to this, it will become minus 1 by 2. Then root L by C into 1 plus r by j omega L into 1 by 2 into 1 plus g by j omega C into minus 1 by 2. Now again I am expanding here. From binomial expansions, 1 plus x whole power n equal to 1 plus x by 2 factorial plus up to so on. 1 minus x whole power n equal to 1 minus x by 2 factorial up to so on. So similarly root L by C into, just first expanding this, 1 plus x by 2 factorial. X means this value here. So r by j omega L into 2 factorial means 2. And now 1 minus, here it is minus 1 minus g by 2j omega C. Now multiplying internally, first I am multiplying these two terms, that equal to square root of L by C into 1 into 1 into minus g by 2j omega C minus g by 2j omega C plus this one into this one, r by 2j omega L, this one into this one, minus rg by r into g, rg by 2 into 2, 4 j into j square, omega into omega square LC. Here also I am neglecting higher order terms, neglect higher order terms, because here it is the high frequency. Then by multiplying this internally, I am getting here square root of L by C into 1 minus root L by C into g by 2j omega C plus root L by C into r by 2j omega L. Now we have to take some common terms. What are the common terms we are having here? Then we have to take, that is equal to square root of L by C plus j by 2 omega. I am writing as a common term, or else we can let 1 by 2j omega as a common term. 1 by 2j omega into, here it will become root L by C into here is G by C, and here is minus because there it is plus, when we take plus 1, just take here minus, take here minus J by 2j omega C, it will become this one, and minus into minus plus square root of L by C into R by 2j omega is common, R by L. Okay, leave it like this. We are having here the expression for characteristic impedance.